Again, guys, this practice final that we're going to work on is mirroring the final exam. It's almost identical to it, all right? So let's go through each one. Now, if you understand this, you'll really understand the final, because the final is multiple choice right here. It's open response. So number one, we want to solve this quadratic equation that's set equal to 0. Any ideas? Factor and then split it and solve it with the zero product property. That's the best option. Of course, you could use a quadratic formula, but it's a lot easier to factor, split, and solve, especially because the a value right here is 1. So if you have h squared, then you could just jump to factoring h right here, h right there, and simply think what times what is a c value that if you combine together is a b value. So what times what is negative 18 that if you add together is positive 7? Positive 9 times negative 2. That's exactly right. So that is the factored form. It's still equal to 0. Now the zero product property says that if you have something times something and it's equal to 0, then that first something could be 0 or the second something could be 0. So that's what we're going to do. We're going to take both of these and set them each equal to 0. So let's solve both of them. Minus 9 on both sides. H equals negative 9. Over here, plus 2 on both sides. H equals positive 2. Those are your two answers for number 1. Now, again, I want to say or remind you that this is a multiple choice final. So on the final exam, let's say you're looking through your multiple choice answers and it looks something like, I mean, this has nothing to do with this question, but let's say on the final exam you see something like 2 plus or minus 3 square root of 2 over 2, something like that, yeah? And let's say that's option A, and then option B also looks like that. It has like a 3 plus or minus. So if you're seeing this type of format, right, then are you going to try to factor, split, and solve if all your multiple choices look like this? What are you going to do if all your multiple choices look like this? Quadratic formula, that's right, perfect. Okay, so anyways, we don't have to worry about quadratic formula on this one because it is factorable. It's nice and easy. Okay, let's move on. Number 2, graph the function. This is something like we've tested on most recently. This is a quadratic function. It is a parabola. There's several things we could know about this parabola just based on the a value. So if the a value is positive, it's opening up. If the a value is negative, it's opening down. So in this case, it's going to open down. Let's go through the steps here. Do we want to use standard form or vertex form? Anybody? You know what? I'll explain both. Whatever. Just in case. So standard form is ax squared plus bx plus c, right? So your a value is negative 2. Your bx term, the b value is not there. So the b is not there, but the c is 3. So if you're doing standard form and you want to find the vertex, which is a coordinate, you must use the x equals negative b over 2 times a. And we just said that the b value is not there. There is no middle term, right? There's ax squared and there's c, but there is no middle term b. There is no x term, right? So there is no b value, which means that the b is 0. So if you plug it in with parentheses, you're going to have 0 over 2 times negative 2. That's still going to be 0 whether it's positive or negative, divided by negative 4. And we all know that 0 divided by any number is 0 for x. Now, if you already have 0 for x, you need to plug that in to find the y value of the vertex. So if you plug in 0 right in there, it's going to be 0 squared, which is 0, and 0 times negative 2, which is still 0, and 0 plus 3, it will be 3. So the vertex is 0, 1, 2, 3, and you put a dot right there. Right after that, you draw your axis of symmetry. And then after that, of course, you need some coordinates. So you could go to an XY table, or to be quicker, you could use a pattern 1, 1, 2, 4, 3, 9. But remember, this pattern right here is only when your a value is equal to 1. And right here, we obviously have our a value equaling negative 2. So the negative, who cares? That just tells us that it opens down. But we do want to modify the outputs. We want to modify the outputs by 2 because the a value is 2. So I'm going to multiply by 2, and I will get 2. I need to multiply the 4 times 2, and I will get 8. And I need to multiply the 9 times 2, and I'll get 18. Of course, 318 is going to be off the graph. But this is my new pattern, 1, 2 instead of 1, 1, 2, 8 instead of 2, 4, 3, 18 instead of 3, 9. So again, we know that this opens down because it's negative. So I'm going to go 1 over and 2 down, 1 over and 2 down. That would be right here. Then I go back to my vertex, and I want to go 2 over, 1, 2, 8 down, 1, 2, 3, all the way down 8. That would be right here. Okay? So let's put a dot right there. And then we need to map it over to the other side of the axis of symmetry. And we're done. Here's our slightly slimmer parabola. It's vertically stretched by a factor of 2. It's opening down. If I were to ask you for the range, you would say the range is y is less than or equal to positive 3 because it's below the y value of positive 3. But they don't even ask this. Whoa, I am so sorry. What just happened? There we go. Whoops. So they don't even ask the axis of symmetry or the domain or any of that stuff, but it's important to know. On the multiple choice test, just by being able to find your vertex, 0, 3, you'll be able to know that it's right here. And just by knowing that it opens down and a little bit narrower than the usual, you should be able to identify which is a correct multiple choice answer. Let's move on to number 3. Now this is stuff that we haven't seen in quite a while. So number 3, it says right there geometric sequence. And in Algebra 1, we did arithmetic in semester 1 and geometric in semester 2, early semester 2. So arithmetic was where there was a common difference, and geometric is where there was a common ratio. You guys remember that? Arithmetic was a common difference, and geometric is a common ratio. So if they tell you that there's a geometric sequence right here, 1,458, and then the next number is negative 486, and the next number is 162, and they're telling you that it's a geometric sequence, what they're really telling you is that you have a common ratio. And we need to find out what that ratio is. Now remember, to find the common difference or ratio, you pick a number, and if you're trying to find the common difference, you take this number and subtract the previous one from it. But if you're trying to find a common ratio, because it's geometric, you're going to take a number and divide it by the previous number. Okay? So you could do negative 486 divided by 1458, or you could do 162 divided by negative 486. It's totally up to you. Either way, you're going to get the same ratio. So let me go with the smaller numbers. I'm going to go with 162, this guy right here, over negative 486. So what we need to do is reduce this fraction. So if you have a Casio calculator, now some of us are going to be lucky enough to get here early enough to get the Casio. There's only half of the class set is Casio, the other half is Texas Instrument. So right here, all you have to do to calculate that ratio, to simplify it, is 162 divided by negative 486. If you type that in, 162 divided by negative 486, and you hit the enter button, the equals button down there, it will give you the reduced fraction, the common ratio of negative 1/3. Okay? So that guy, the common ratio is negative 1/3. Now, if you don't have a Casio, then you will have to reduce this thing, maybe the old-fashioned way, maybe divide this top number and bottom number by 2, get a new fraction, divide by 2 again, or you could try dividing by 4 or by 16, just with the calculator, keep dividing top and bottom till you get to this value of negative 1/3. Anyhow, once you have the common ratio, we need to have memorized the a sub nth rule for the geometric sequence. So the a sub nth rule is a sub n equals a sub 1 times common ratio to the n minus 1 power. I know that sounds crazy right now. We haven't seen this in months, right? So hopefully we kind of seem familiar with this. If not, we need to get familiar with this because it's coming out on the final, okay? And each question counts. So we just found out that the common ratio was negative 1/3, and that's going to go right in there. Does anybody remember what a sub 1 is? Does anybody remember what a sub 1 is? The first number on your list. Perfect. Okay, so let's actually just plug in those two numbers. So we have our a sub nth rule is really going to be the 1,458 parenthesis. Let's plug in our common ratio r, which is negative 1/3 right in there. And then to the n minus 1 power. Now, ladies and gentlemen, this is the function. This right here is the machine that will produce this list. Let me show you. If I plug in a 1 right here, it's going to give me the first number on the list. Let me show you. Plug in a 1. 1 minus 1 is 0. Anything to the 0 power is 1, and 1 times 1458 is 1458. If I were to plug in the number 2 into n, it'll actually give me negative 486. If I plug in a 2 right here, it'll be 2 minus 1, that's 1. You have a negative 1/3 times 1458. If you multiply it, it will give you negative 486. Okay? So it really does produce this list of numbers. Now, ladies and gentlemen, let's really understand the finale part of this question. It says, find the 7th term of this sequence. Okay? Find the 7th term of this sequence. So here's your first term, your second term, your third term, your fourth term, your fifth, your sixth, your 7th term. That number is the number you want to represent on your answer or identify in your multiple choice answers. So if you want the 7th number, what you're really going to be doing is taking this a sub n and plugging in 7. So the notation would be a sub 7. The work would be 1458 times negative 1/3, but to the 7 minus 1 power if you're plugging in 7. So you really have 1458 times negative 1/3 to the 6th power. So you could type it all into the calculator, 1458, and then you open some parentheses with the parenthesis buttons right there. Type in, you want to type in negative 1/3. So you're going to type in negative 1 divided by 3. Remember, a fraction is really a division problem. So negative 1 divided by 3, close parenthesis. And then on the Casio, you could use this button right here to get to the exponent position, x to the little box up there. On the Texas Instrument, you have to use the caret button. So here's the Texas Instrument, and this is the caret button I'm talking about. You need to use this button in order for you to get up in the exponent position. And on your Texas Instrument screen, you will see the caret button, and type in 6. This is the exponent of this common ratio. It is a little bit old school, this calculator. This one obviously is a little bit nicer. So when you hit equal, the answer is 2. So that is your answer for the 7th term will be the number 2. So the answer is a sub 7 equals 2. Now let's go back just to really understand what we just found. Check this out, guys. So the common ratio of negative 1/3, that means that when you multiply something by 1/3, you're really dividing by 3. So if you take 1458 and divide by 3, or by negative 3, because it's a negative, you'll get this next number. And then divide by negative 3, you'll get this next number. If you divide by negative 3, you get the next number, and so on, till you get to the 7th term on this list, and that 7th term will be the number 2. I hope this refreshes your memory. Let's move on to number 4. 4 is cake. It is a quadratic equation. All quadratic equations you want set equal to 0. So you could either use the quadratic formula, or so you could factor and then split using the 0 product property to solve. But anyway, let's move that 6x over to the other side. 6x, you can't combine it with anything, so let's rewrite it. Now after that, we could use the quadratic formula, or we could try to factor, split, and solve. I'm going to go with the quadratic formula. So my a value is 3, my b value is -6, my c value is -4. There's my quadratic formula. X equals -b plus or minus square root of b squared minus 4ac divided by 2a. Then we're going to replace the b's, the a's, and the c's with parentheses. And then we simply plug in those values. The b value is -6. The a value is 3. The a value is 3. The c value is -4. So we always start by working out the discriminant. So on the inside, we have an exponent, -6 squared, that's 36. I'm just going to write it right here on the side. And then I have 4 times 3, which is 12, times 4. 12 times 4 is 48. Now, I need to know if I'm adding 48 or subtracting 48. The best way to do that is to understand that there's one negative here and another negative. A negative times a negative equals a positive. So we end up with a plus between the 36 and the 48. So that means we would have 84 as our discriminant, okay? So 84 is our discriminant. Now this, you could calculate on the side, but you do want to replace the b squared minus 4ac with 84. So let me rewrite what we have inside the, in the quadratic formula right now. X equals 6, because a negative and a negative is a positive, plus or minus the square root of 84 over 6. Now 84 is not a perfect square number, but maybe we could break it down with multiplication to get a perfect square number. Okay, so let's actually jot down the square root of 84 right here on the side. And what do you guys want to break it down by? 84 divided by what? Give me a perfect square number. 4, okay. 4 will work. 84 divided by 4 is 21. So if you rewrite it as 4 times 21, and then you split that root, we're going to get 2 square root of 21. Yay? Yeah. So the square root of 84, I need to replace it with 2 square root of 21. So I'm going to take the square root of 84 and just remove it and put the new value 2 square root of 21. So my answer is x equals 6 plus or minus 2 square root of 21 over 6. Now, this answer is a fraction. Of course, we're not going to get nice answers because the square root of 21 can't be broken down any further. If you're thinking 3 times 7, neither of those are perfect squares. So you're kind of stuck there with the square root. However, we do notice that this one and this one and this one, all 3 terms are divisible by 2. So it's like a fraction that needs to be reduced. We're going to reduce everything by 2. That becomes 3. This becomes 1. This becomes 3. So our final answer here will be 3 plus or minus square root of 21. You could put the 1, but I'll be honest with you, on the multiple choice, the 1's not going to be there. It's like saying 1x. You don't have to say 1x, you just say x. And it is divided by 3. So this would be your final answer that you need to identify on the multiple choice part of the final exam. Might as well jump to number 5. Factor completely. So it's not an equation we're not solving, but we could factor. And because the a value is 1, it's really easy to think of this. What times what is 28? That if I combine together is negative 11. Now if you're struggling, go ahead and make a list of numbers. 1 times 28, 2 times 14, 3 times, nope, doesn't work. 4 times 7, 5 doesn't work, 6 doesn't work. That's it. Those are the 3 possibilities. 1 and 28, 2 and 14, and 4 and 7. Which pair of numbers combines together to give us the middle value, which is negative 11? The 4 and the 7, right? However, if I add 4 and 7, that gives me positive 11, and we know that we want a negative 11. So we have the right numbers, we just have the wrong signs. So we're going to replace it, or we're going to change the signs and make it a negative 4 and a negative 7. So inside we go negative 4, negative 7, and that's it. That is the factored form. By the way, I'm not sure, I believe the way the final exam is going to give it to you, they're not going to give you this as option A. Okay, they're not going to give you that as option A. They're going to ask which of the following are one of the factors. Okay, they're going to say which of the following are one of the factors. So they're going to give you something like this: G plus 4. Option B, G plus 7. Option C, let's say G minus 1. Or option D, G minus 4. So what would the correct answer be if they're asking for one of the factors? One of the factors. This is how they're going to ask it on the test. Now let me tell you why they don't put this as option A. Because if they did put that as option A, you would be able to just distribute G times G, G squared. g times -7, -7g, -4 times g is -4g. That gives me the 11g. So they're not going to give you the full answer. They're going to say, which of the following is one of the factors of this guy, right? At least they're going to ask that on one of the questions. So which would be the correct answer here, A, B, C, or D?
D.
That would be D, because that's the only one that appears right there, okay? I'm not sure if it's this particular question or if it's a different question, but I know that they do ask this type of question when they ask you to factor. They don't just give you the answer straight up like that, g minus 4, g minus 7. So just so you don't get confused, this is the answer right here, the completely factored form. Make sure you understand that. Now I'm going to stop right here. I'm going to start on number 6 on a different video, and we're going to start solving this system. This is way back from early part of semester 2.